Hello everyone and welcome to .NET Core Central. In today's video, I'm going to walk through how to use migrations with Entity Framework Core. Now in Entity Framework Core, we can use code for connecting to database and retrieving and saving data. And for most part, we can use inline queries or out-of-box APIs to do that. Now the advantage of using inline queries or the out-of-box APIs of Entity Framework is that the deployment becomes really simple. And in the era of microservices and CI/CD, it's extremely important that the deployment is really easy and fast to do. Now the only disadvantage that we have with RDBMS is that the data definition language or the DDL scripts are usually executed outside of the entire flow of deployment, and that makes things out of sync. And sometimes, it's harder to keep a track of what changed and what not, because the changes in data definition are in the SQL Server, whereas the changes in the code is in Visual Studio and some other location in SourceSafe. Well, there are ways to manage it. You can create a Visual Studio project and you can keep all your script there, but it's still not completely integrated. You still have to execute it outside of this. And now one way to solve the problem is you can also execute all the DDL command as a part of your code. So that's one way to go about it. The other way is to use some sort of migration framework like the Entity Framework Core migration. The advantage of using things like Entity Framework Core migration is that it is code as SQL. So you would be using Fluent API for creating and updating tables and things like that. So it's much more easier to comprehend and manage. And also the roll forward rollbacks become really easy and non-convoluted. So having said that, to try it out, let's first create a project. And if you have not gone through Entity Framework, using Entity Framework for retrieving and saving data, well, I have a couple of videos. I'm going to share the links for the videos up there in the left corner, so you can visit to those videos and view them fast if you are new to Entity Framework. If you are not new, then you can continue. So first, let's create a new project. And for the project, I'm going to go ahead with ASP.NET Core Web Application. I'm going to name the application as EFCore migration.demo. And here I'm going to go ahead and select API. I'll keep .NET Core 3.1 and I will not enable Docker for this one. Well, you can use it, but for what we are going to demo today, Docker is really immaterial because we're just going to demo migration and it can run inside a Docker or outside a Docker. It really doesn't matter. Once the project is created, I'm going to first go ahead and add the necessary NuGet packages we need for this demo. And for that, we're going to add the Entity Framework Core. So we are first going to install the Entity Framework Core NuGet package. And since in this example, we are going to deal with SQL Server, so I'm going to install Entity Framework Core.SQL Server. And then finally, I'm going to install Entity Framework Core.Tools. The tools is the one, as you can see in the definition itself, it allows for migration. So this is the command: add migration, drop database, scaffolding, DB context, and things of that nature. Though we are not going to use these commands in the command tool, because the goal here is to do everything through code so that we can leave the magic outside and understand how the internal works. So I'm going to install this. Okay, once all the installation is done, the next thing I'm going to do is I'm going to first create a class which will be for the DB context, which is the gateway to the database. And for this, let's consider that we have employees table and we're going to deal with employees. So for that, we're going to create a employee context. Once the employee context class is created, the first thing we're going to do is derive this from DB context. And for DB context, we have to add the namespace for Entity Framework Core. So I'm going to add that. And then once we do that, the next thing we're going to do is we're going to create a property. It's going to be a DB set, and it will be a DB set of employee. And then the property name will be employees. Now the employee type doesn't exist, so I'm going to go ahead and create a new type, employee. And before I go and update all the properties of employee, let's finish up this context class. Next thing I'm going to do is create a constructor. Now for the connection string, there are two ways to do it. One way is we can go ahead and override the onConfiguring method, and onConfiguring method provides a DB context options builder where we can configure the SQL Server and provide the connection string. And the other way of doing it is through constructor. And for the constructor, if I do a base here, you can see that the base also has a overload which takes DB context options. So this is the one that we are going to use. So here we'll pass DB context options, and we're just going to pass it to the base. And DB context option is the place where we will set up the SQL Server, and this will be done in the dependency injection container itself, and I'm going to show it once we go there. So now our employee context class is created. Next thing to do is to go and update the employee with the properties that we need. And for the employees, we are going to keep it simple. We are going to have ID, which will be auto-generated number, string first name, and then finally another property, string last name. Let's also add address. So these are the 4 properties that we have in the employee object. Now that the employee object is completed, the next thing to do is we're done with employee context, we are good with employee object. Let's create a controller. So we'll create a new controller, and we'll have a API read-write controller, and we'll name it as employee controller. Once the controller is created, what I'm going to do is I'm going to use the employee context to get and set employees. Now, normally I will create an employee provider which just deals with the get method, and the employee repo which will do the updates and creates. But for simplicity and for the interest of time here, I'm just going to take employee context as a constructor input. So in the constructor, I'm going to have employee context, which will be passed on by the dependency injection container. And then in the get method, all I'm going to do is I'm going to say employee context dot employees, and I'm going to change the return type to employee enumerable of employee. So this is done. The next thing is the post, and in post I'm going to change this from string to an employee object. And then here I'm going to take the employee context dot add. I'm going to add the employee, and once the employee is added, I'm going to again do employee context dot save changes. So this will save changes into the database. So we're done with the get and the post method. I'm going to get rid of the other methods for the time being, as I'll not implement this right now. So let's keep it clean. Okay, so we have done implementing this class as well. Now if I run this application, well, before I run, I have to configure the dependency injection container. So let's do that. So I will go here, and then in this place I can do services dot add db context, and I can say employee context. And then here you can see I have a couple of things going on. So first thing is action, which is going to give an object of db context option builder. And this is the same thing. If you remember, here we have a db context options. So db context option will be passed by the whatever we set up in the option builder. So we can say option builder, and here going to say option builder dot use SQL server, and let's just add the namespace entity framework.core. And as you can see, this one takes mandatory parameter of connection string and an optional parameter of another action which gives handle to a SQL Server DB context option builders object. So we'll come to that later. First, let's provide the connection string, and for connection string we're just going to pick it up, configure it from configuration, and we can say it's connection. And then the next one is the SQL Server options. So we can say SQL Server options dot, and here we're going to provide the migrations assembly. This is critical because we are going to use migration. We have to let know what is the assembly where the migration information is available, and that assembly is nothing but the current executing assembly. So we'll do assembly dot, and we'll add the system.reflections namespace for the assembly, and we'll do get executing assembly. Let me take it to the next line so that it's visible. Get executing assembly dot get name dot name. This will give the name of the current executing assembly. So once we do that, we're all set and we can run the application. But once I run this application, if I go to API/employee, which will execute the employee controller, I'll get an error because the database is not created. But even before I do that, I have to provide the connection string in the configuration. So I'm going to go ahead and do that. In the app setting, I'm going to add connection, and for connection I'm going to pick up an existing connection string that I have, which connects to my database, and I'm going to paste here. And for the database name, I'm using EF demo. So we have to create a database named EF demo. Now there are a couple of ways of doing it. One thing is, for database we can pass master here, and with the code we can check if EF demo database exists, then don't do anything, otherwise create. That's one way of doing. But for most cases, if we are using cloud-based managed database or even in-premise databases, creating a database is a one-time thing and it's easier to manage, and that can be done even before the code is deployed. So this is not a part of the problem that we are trying to solve. The problem that we are trying to solve is how to migrate everything else, not the database. So I'm just going to go ahead, and for simplicity I'm just going to create a new database. I'm going to name it as EF demo, the same name in the configuration, and right now the database is created. It doesn't have any table, nothing, but it's ready for us to use. So now I'm going to run this application, so at least the database is there. So once I run the application, if I go to API/employee, I'm going to get the error as expected. It is going to say employees table doesn't exist, which is an expected behavior. Now it's time to go into the application and add our migration script so that we can create the employees table. And this is what is the main purpose of this video. So let's start. I'm going to create a folder called migrations. And inside the migration, I'm going to create a new class. And I'm going to name the class as migration underscore 04/05/2020. That's today's date. And the time is 10/10/00. Let's say this is the time. For the name, I prefer to postfix it with the timestamp because it's easier that way that we can remember which migration script was done at what point in time. Once we do that, the next thing I'm going to do is I'm going to derive this class from the Entity Framework Core migrations. And for that, I have to add the namespace Entity Framework Core.migrations. And once I add this class, it has an abstract method which is up that must be implemented. So I will go ahead and implement this. Add the namespace for this attribute. And along with the up, I'm also going to override the down method because we're going to do both up as well as down. Up is when we are migrating up, so basically the newly created scripts. Down is when we want to roll back. So for up is where we're going to create the table. So we're going to say migration builder dot create table, and for the table I'm going to give the name of the table, and the name of the table is nothing but employees. And the next thing is the set of columns which I'm going to create with the help of column builder. And you can see the column builder, for the columns it's a func which gives column builder as an input and expects a type to be returned. So for that I'm going to say columns column builder, and for the type I'm going to create a new anonymous type, and where I'll have ID equal to column builder dot columns, and ID is an int, and then I'm going to say nullable as false. And the other thing I want to do is I want to make sure that the ID is an identity column auto incremented. So for that, what we are going to do is we're going to use dot annotation, and on the annotation we can pass SQL server colon identity, that's the annotation string, and for the value we can say 1, 1. So that's the ID. Once the ID is created, the next thing is the first name, and first name is again a column of string, and here also we'll say nullable as false. Then last name, for last name also it's the same thing, and then finally address. And for address, what I'm going to do is I'm going to make nullable as true because address is not mandatory. So this is where we declare the column. After column, the next thing I'm going to do is I'm going to define the constraints, because I want to make sure that ID is a primary key, and you can see that for constraint it's again an action, and the actions gives us a create table builder object. So we'll say create table builder object dot, and here's the primary key, so we can use the primary key. The primary key has a name, and for the name we will use the standard pk underscore the employee ID underscore key. And then for the object, if you can see, is the columns, so we are going to say this is also an expression, a func, and here we can say ID. So this will create the constraint, and now technically we have created a table with the name, a set of columns. One of the column is an identity column, and then we created a constraint where we created a primary key. So as you can see here, we are creating the entire table through a Fluent API, and it's really easy to understand and maintain also in future. And now it takes us to the next step, which is the down. For down, because this is the first time we are creating the table, all we are going to do is drop table, and we're going to provide the table name, drop table of employees. So now this migration class is created. The next thing we have to do is we have to add a couple of attributes for this class to be available during migration call. If you remember in startup here, we provided that the migration assembly is the executing assembly. So once we provide that, the internally the entity framework component, when we call the migrate, it goes through the assembly, finds out all the classes which implements this attribute, and the attribute is migration, and it takes an ID. For the ID, we are going to give this class name. This is the identifier. And the next thing we're going to provide is DB context. That's another attribute, and it is part of the entity framework core infrastructure. And this one takes a type, so we'll provide type of employee context. So once we do that, this class is all ready to be executed. Now we have to figure out where to execute it. Now there are two ways of doing it. One way is we can just at the end of this function, we can get a handle of the employee context and call the migrate, or we can create an extension method on application builder. Or the third way to do is we can, in the main itself, we can create an extension method on iHost, and after the build process is done, which is this entire process, we can call something like migrate, and then we can call run. So for the simplicity, I'm just going to do it here. So what I'm going to do is I will add the I service provider, and then here what I can do is service provider dot get service of employee context dot database dot migrate. And once I do that, the migration process will trigger and it will create the table necessary for this entire process. So now let's run this application again and see what happens. So now if I do API/employee, we can see that now it is returning an empty array. It is not throwing an error. So let's go into the database and see what happened there. So if we go into the database, let's refresh this object. And once we expand the table, we can see the employee table is now available, as well as this interesting table of entity framework migration history. So the entity framework migration history is nothing but a table where entity framework keeps a record of what was executed. And you can see that this is the exact ID that we provided in the attribute is what kept as a history. And this helps entity framework core to upgrade or downgrade a particular migration. The other thing I'm going to do is I'm going to go into Postman and create an employee using the post method and re-execute and make sure that the identity is working as expected. Though we can check the column here and we can see that in columns the ID is a primary key, and if we go to the properties we can see that the identity is set to true and the identity seed is 1 and increment is 1, the way we provided in the code. So now let's go to Postman and I have this post method here which gives first name, last name and an address. I'm going to execute this, and if I execute I can see I got a 200 back. Now if I go back to my browser here and re-execute this, I can see that the ID, first name, last name and address is appearing here. If we go to the management studio and do an execution, we can see the same record here. So this is all I had to cover today in terms of migration. There are a few other topics that I want to obviously cover in migration in terms of what happens if a table changes, what happens when you add a new table, how the rollback happens, and I'm going to cover all these in the next video. If you like this video, please give me a thumbs up, and if you are not subscribed to my channel and if you think my channel is giving you value, please subscribe to it. Thank you so much for watching.